Hey guys, just want to talk a little bit about troubleshooting, especially for newer techs that are newer to troubleshooting things and just kind of feel lost. I wanted to just give some helpful tips. Um, Three things that have really helped me out in becoming better at troubleshooting is really figuring out what you need to know before you start troubleshooting something. And there's three things that you really should know before troubleshooting anything. And if you follow those three things, if you understand those three things, it'll make you better at troubleshooting anything. The first thing is components, understanding your components, everything that's involved. The second thing is understanding the sequence of operations. Everything has a sequence of operations. And I see so many technicians that just handicap themselves because they refuse to learn the sequence of operations. And then the third thing is just having a process or a system of how to tackle a problem. It doesn't have to be, I'll show you what I use, what I was taught, my system, but you can develop your own or learn other systems. The point is having something to fall back on when you're working on something unknown, and having a system just really helps you out. Until you learn that equipment better, then you might follow a different system or tweak it a little bit. But first off, we'll talk about components. I didn't bring up any pictures or slides, but because it's pretty self-explanatory, you just need to know the individual components, what they are, how they work, have a general understanding. So, things like relays, transformers, switches, compressor, just the different components and whatever you're working on. A board, a control board, sensors, what they do, what their inputs and outputs are supposed to be, things like that. You're not going to know every rating for every component you're working on, but you can figure that out in the field. You should at least have a basic understanding, though, of what the components are. Like, what is a capacitor? What does it do? What is a relay? What does it do? So that's the components part of it. If you don't already have a good understanding of the components, that's really something I would suggest learning. Just start learning what the components are and how they work. The second part, which is super important, is understanding the sequence of operations. So for some equipment, it's kind of hard. You really got to just learn in the field, learn from senior techs, learn from studying the wiring diagram, watching how it works, and then figuring it out from there. But I use this ice machine as an example because they actually provide you with the sequence of operations, and it'll help you in troubleshooting. So this is for a Manitowoc ice machine, remote condenser. And the first thing that happens when you turn on the ice machine, it's going to purge water. So as you can see, before the compressor starts, the water pump and water dump solenoid are energized to purge the ice machine of old water. This feature ensures that the ice making cycle starts with fresh water. So, right when you turn it on and it's in water purge, you know that the dump valve is going to be energized. Then it's going to go into refrigeration system startup, so pre-chill. And this just explains what's happening with the refrigeration system. So the harvest valves, air pumps, liquid line solenoid valve, and CVD relay are all energized. After 10 seconds, the harvest valves and air pumps de-energize. Then you go into the pre-chill. The compressor lowers the temperature of the evaporator, so that's when it starts getting cold before it before the water's flowing on it. The water fill valve will energize and remain on until water completes the water level probe circuit. So your fill valve is going to be open and energized. Then it's going to go into freeze. The water pump energizes and water flows over the evaporator. After water contacts the water level probe, the water fill valve de-energizes. The control board will automatically cycle the water fill valve. And so you get the idea. You can read these for yourselves, but it tells you when something is supposed to be energized, what components are involved, and what they should be doing, and the different cycles that it's going to go into. And the reason why this is so important is because if you're testing something and you're thinking that it's not working, but you're testing it in the wrong cycle or testing it when it's not supposed to be energized, you're going to condemn a part or something that may not actually have any faults in it. So it's just super important to understand the sequence of operation, understand the what all should be happening in different phases of the operation of the machine, what parts should be energized, what their inputs and outputs should be, and it'll just really help you for troubleshooting. The third part, so we talked about components, we talked about sequence of operation, but the third part is going to be having a system of troubleshooting something. The one that I was taught was the power path part. So I tend to when I'm working on something new, I'll learn the sequence of operation roughly. I'll familiarize myself with all the components involved, and then I'll start diagnosing the electrical first. You don't always have to do this, and in a lot of cases it might not be where you should start, but this is just my fallback when I'm approaching something new or a new piece of equipment. And so the first part, power, that's talking about your supply power. So that's making sure that you have whatever the voltage you're supposed to coming out of the wall, wherever at the receptacle, if it's a machine that plugs in. If you're getting 120 or 240, you're getting the proper voltage. So you follow the power and you follow that path. So that goes into the second. So there's 3 P's: power, path, part. So after you find the power, so if we look at this wiring diagram, you'd look at your L1, L2, L3. So you'd check, make sure you're getting the right voltage. And then you follow that path. And this is where understanding wiring diagrams is so important. Obviously, we wouldn't just be following this on the wiring diagram. We would actually, physically check where it plugs in the wall, or wherever at the disconnect, if it's an HVAC system, wherever that main power source is coming from. Then we follow that path until we get to parts. So say we follow the power, we follow the path, and the first part it takes us to, if you look at this wiring diagram, is the contactor. Say we're getting the proper voltage to our contactor, which is our first part in the system that we're encountering, but the contactor is not closing. It's not sending power through. Well, then we know that contactor is bad. But say, for example, we test it and the contactor is doing what it's supposed to. It's got proper input, got proper output. So then we continue down the path. And that's where it gets tricky, is because sometimes the path branches off and multiple things are happening at once. And that's where understanding the sequence of operations comes into play. You got to understand that not just one circuit might be energized. There might be multiple things happening. So we follow the path, and say we follow it to the fan motor over here in the upper right corner. And we have voltage, the proper voltage to our fan motor, but it's just not working. So then we know, we've reached another part that we need to check. It could be the capacitor is bad, so maybe we check the capacitor. Maybe the fan motor's shorted to ground, and we check that. And if we check that out and everything's good, we continue the path and we just keep doing that, following the path, and checking each part that we encounter and making sure that it's working until we reach the part that is not working. And that's how we determine the fault. One thing to keep in mind is that once you get to the part that's not working, that's only one half of the battle. Then we got to determine why. Sometimes it can be that that's not the part that's bad. It's just we missed something that it's not getting. Maybe it's not sensing something. Maybe there's an error, a temperature probe, or some kind of sensor that's not letting that part work, not getting the proper voltage or not getting the proper control voltage. Maybe there's a relay or something. So it's just important to not automatically condemn the first part we encounter that's not working, but it helps us narrow it down and isolate why the system's not working. And as you get more comfortable, you'll start to figure out shortcuts. You'll realize that maybe you don't need to start from the your supply voltage and follow it all the way down the wiring diagram. Maybe you'll skip to, for example, an HVAC system. You might skip. One of the first things I check is I'll check my thermostat. If I'm getting 24 volts to my thermostat, then I know I'm getting voltage to my air handler, or something like that. So you might find little shortcuts just to make it a little bit faster, and isolating where the problem is. So that's just some tips and tricks for troubleshooting. Once again, just to summarize, that's understanding the components you're working with, the sequence of operations, and having a system. And in my case, the system I use is called Power Path Parts, and you're just following the electrical. You're just following the system, the circuit, whether it's electrical or whether it's refrigeration, until you find the part that's got a fault in it. Thanks, guys.